All right, in this video I'm going to be doing a word problem on vectors. We've got a magic carpet that's flying north 30 degrees west at a constant speed of 600 miles per hour. The wind is a constant 75 miles per hour in the southern direction. It says find the actual speed and direction of the flying carpet relative to the ground. That's a 2 right here. So this is a common problem in textbooks. I made a flying carpet instead of a plane just because it's fun. But anyway, magic carpet is flying this direction. So what we need to do is take this and turn it into a vector. Then we're going to take the wind and turn it into a vector. When we have those two in their component form, right, the magic carpet and the wind, what we need to do is add them together. And then we will be able to figure out from that vector what the actual speed and direction is. Okay? So first step, we need to draw our coordinate axis, except I'm going to label it a little differently. I'm going to label that up here as north, this is that, then south, we got west and east. Okay, so we got this magic carpet. It's going north 30 degrees west, which means perfectly north and then a little bit west, 30 degrees in fact. So that means this angle right here is 30 degrees. Okay, its magnitude is its speed right here, so 600 miles per hour. Right? So I just took those words and drew the picture of it, right? And now I can use right triangle trig to resolve the vector, meaning I can write it in its component form. Okay? So if I drop down a little perpendicular here, I've got a right triangle. And I can solve for the x component and the y component. The x component is going to be negative. You can see you're going left here, right? So it's going to be negative in the negative x direction, but the y component is going to be positive, right? So I'm going to label this as, let's see, the magic carpet, so m, and that's going to be equal to the change in the x component and then the change in the y component. So I'm going to label those. So the change in the x component is this part right here. Now how would I find that from a right triangle? You would use cosine, and you'd use cosine of this angle right here. However, we know cosine needs to be negative over here because we're in the negative, we're in the second quadrant. And if I just use this as a regular triangle, if I do cosine of 60 degrees, I'll get a positive number. So what I'm going to do is I'm going to do cosine of its supplement. So this part right here plus the 30, that's 120. So if I do cosine of 120 degrees, that's going to be the same value that we want to of the adjacent, the change in x, over 600. All right. So you need to rewind back to your right triangle or your unit circle for the logic behind that. It's going to give me the value that I want when this one was 60, except it's going to make it negative for me because cosine of 120 is negative 1/2. Okay. And to solve for the change in x, I multiply times 600 on both sides to get rid of this divide by 600. So my change in x is going to be 600 times the cosine of 120 degrees. Okay? So my component form of this magic carpet vector is starting to look like this. Now, what's the y component going to look like? Well, it's for the same reasons that the sine of 120 degrees, and again I'm using 120 just to be consistent, will give me the opposite, which turns out to be the change in y, over the hypotenuse, which is the magnitude of that vector, 600. And if I solved this for the change in y, delta y, I'd get something very similar to this except with a sine. 600 times sine of 120 degrees. Okay? So what we've done, the steps there, look at the words, make sure you understand what the north 30 degrees west was. Draw the picture, and then look at it so you can look at the right triangle and write it in its component form. That's the first big step. Once I've done that, then I can do the same thing with the wind, add them together, and then from that vector we can start looking at what the magnitude of that one is and which direction it's going. All right? So the wind is at a constant speed of 75 miles per hour in the southern direction. So let's see, that's going to be blowing just this way, right, straight down. Now I could draw it from here, but just so that you can see the vector, I'm going to draw it over here. It doesn't really matter. As long as the magnitude and direction are the same, I can move it anywhere I want. So this is 75, right? And it's going down. So when I write this vector in its component form, it's going to look like this. The air, or I guess I could label that wind. Let's label it wind. W equals, the x component is 0 for this one. The x component is 0 because I'm not moving left, right at all. But I am going down in the y direction. So that's going to mean negative 75, right? So now I've got these two vectors in their component form, and I can add them together. And when I add them together, I'll get m plus w, and I'll know where the magic carpet's actually going in this situation. I would expect that the magic carpet would be going approximately something like this, maybe. Probably still northwest, but probably being blown back a little bit. So I would anticipate that its magnitude is not 600 anymore. It's got to be less than that. But I don't think it's perfectly, just 75 miles per hour less. I would guess that it's some variation of that. So let's find out. We've got to add them together. And we add vectors together. We just add their components. So this x component plus this x component. It's just adding 0, so it's really just the same thing. 600 times cosine of 120 degrees. And then this is 600 times sine of 120 degrees plus negative 75. So that's going to be 600 sine of 120 minus 75. Okay? So that vector right there, sorry, it's getting cut off a little bit. Let's see, there we go. This vector right here represents what happens when we calculate for wind as well. All right? In order to find the speed of the magic carpet with the wind component added in, we just need to find the magnitude of this. All right? So we just need to do the magnitude of m plus w, which will equal the square root of the x component squared plus the y component squared. So what are these values? I haven't simplified anything yet. Cosine of 120 degrees is negative 0.5 times 600, that's going to be negative 300. Let's verify that in the calculator. So 600 times cosine of 120 is negative 300. Now, make sure your calculator, hit mode, make sure you're in degrees, right? Make sure you're in degrees. If you're not, if you're over here in radians, arrow over to degrees, make sure it's in the right setting. All right, so it's negative 300 in the x direction, and then I'm going to square that. Plus, and this is, you could have rewritten this all over again if you wanted to simplify before doing this step. 600 times sine 120 minus 75. Make sure you close that parenthesis. All right, and you get 444. So that's the y component. I'm going to approximate this actually. 2 squared. All right. So when I plug all this in, I will get the speed. Let's see what that is. That's going to equal square root of negative 300 squared plus 444.62 squared. And I already did the square root. So we get a speed of 536.36 miles per hour. That's the speed after accounting for the wind. And then the question now is, which direction is it going? All right. So I'm going to kind of redraw this a little bit. To figure this part out, we need inverse trig. So this is going to be going somewhere like this. And the only reason I know that is, one, because I did this problem before, but two, it kind of makes logical sense, right? It's going to be blowing further down. It's not going to be going over this way all of a sudden. So we know the magnitude, we just don't know the direction. And my final direction, what I really want, is from north going west. So that's going to be my final answer. But for right now, I'm going to look at this triangle right here, this little right triangle. And to find this angle, I would use inverse tangent. And I would use inverse tangent originally from my component form of the vector here, right? Because I have the y component, I have the x component. That would be y component here, x component here. So usually you'll see the formula tangent of theta equals y over x, right? So tangent inverse then of the y component over the x component will give you this angle. However, when you do inverse tangent, you only get angles that are in the fourth or first quadrant, which means if I want this angle and I get the angle here, I'm given this angle here, right? So in order to come all the way back around, I would need to add 180. Add 180. Or you could switch the sign, right? But it would still only give you this one. You might want this one, depends on the context of the problem. So just know inverse tangent is only going to give you angles over here or here, not this one. So it's going to give us a negative one, and it won't quite make sense until we kind of add 180 to it. And even then, it'll give us this angle here from the positive x-axis over to here, so we'll have to do a little bit more. So let's see. Tangent inverse of the y component over the x component. That's this over this, which we kind of wrote inside this problem here. So that's over 444.62. You can verify that. You can go back and you'll see if you plug this in the calculator, you'll get these numbers, right? Let's see, that's negative 300. And that's going to give us our angle, right? So tangent inverse of 444.62 divided by negative 300. Whoops. You will get, did I add the negative in? No. You will get negative 55.99. So negative 56, let's call it, approximately negative 56 degrees. Okay, now, like I said, that's not really the angle we want. We want the angle from northwest. So what is this equivalent to from the positive x-axis? That would be the first step. I'd take negative 56 degrees and add 180. That'll bring me all the way around. So that's going to be 124. Right? So the question then is, how far west is that from north? How far west from north? So what's this angle here? Because that's the problem gave us that type of angle or direction in the original part. So in the question, that is. So it's north, and how many degrees west? Well, it takes 90 of this 124 to go north. So let's just do this minus 90, and you get 34. So this is north, and then 34, we're approximating this, degrees west. Because 90 of this was spent going this way, the remaining bit is 34 degrees. So the direction that the magic carpet is going is north, 34 degrees west, at a speed of 536.36 miles per hour. Good luck.